In one of the videos, I've been asked this question about what are vector databases and what are vectors and text embeddings. So I'll try to answer this in a couple of videos. In this particular video, we'll try to understand what are text embeddings slash vectors, right? I'll try to use as less jargon as possible so that this is simply explained. To start with, imagine you're trying to teach a computer to understand a story, right? Computer doesn't understand words or sentences like us. It only understands numbers. So we need a way to turn the words and sentences in the story into numbers so that computer can understand it. That's where text embeddings comes into picture. It acts like a translator between us and computer, right? So the basic idea behind text embedding is we give each word a number or group of numbers that represent its meaning, right? The words which have similar meaning will be closer to each other. For example, if you see in this particular graph, cow, cat, dog, and lion are closer to each other, and they are farther from machine, computer, and software, right? These three are grouped together because they are somewhat related and similar, and they are away from all the animals, right? Similarly, cat and lion are a bit apart from cat and dog because cat and dog can be pets, right? So that's what word embeddings indicate. They help the computer understands our words and stories in a way it can process and then learn from, right? So what I'll do is I'll explain with a simple example. I'll show with a simple example how it looks like. In this particular import, if you notice, I've added an extra import that is cosine similarity, right? I've imported cosine similarity from this, and I've installed this as well, right? If you see pip install scikit-learn, I've installed this. And then first I'm creating an embedding model, right? Using OpenAI embeddings since my OpenAI key is already set, so I don't need to pass it. Next thing is I create a cat, the embedding for the word cat, right? This is how it would look like practically. It has many dimensions, not just a single number. So it has many dimensions. Computer needs this to understand its meaning, right? Let me clear this cell's output. So after showing you the embedding for cat, what I'm doing is I'm creating another embedding object. This time I'm embedding three words, cat, dog, and software, right? So what do we expect? We expect cat and dog embedding to be similar, to be closer to each other. Then let's say from cat and software, right? So let's see what we have done. First, we have stored each embedding. Uh, for the word cat, it will be at the 0th index. So I've stored that, then dog embedding, and then software embedding. And then I'll do a cosine similarity between cat and dog embedding, right? And then convert it into a percentage, and we get a 93.93% match, right? These are similar to each other. Now, this 93.93 in itself doesn't mean anything unless you compare it with something else, right? So we compare that with cat embedding and software embedding, right? So I do a similarity search between cat and software, and what do I get? I get 90.84. Now, do not go by percentages. We only need to look at which one is a better match. So cat and dog are closer, are grouped together closer, whereas cat and software are not so close, right? That's what we expected, cat and dog to be closer and cat and software to be a little far apart. So that's how embeddings work, and that's why embeddings are used. In the next video, we'll learn about why do we need vector databases and what do they provide. So that's it for now. Thank you for watching. Have a good day.